So let's talk about what a circuit is. Okay, so we just talked about what a path was. And basically you can tie a circuit to what a path is. So circuit. When a trip along the edges of a graph closes back on itself, we call it a circuit rather than a path. So basically a circuit is similar to a path. You're taking distinct adjacent edges, traveling along them, but then you're coming back to where you started. So you're going to end at the same vertex that you start at. Now in a path, you end at a different vertex than what you start at. But in a circuit, you're going to end at the same vertex that you start at. Okay, so let's look at maybe trying to find a circuit in this graph here, just to give an example. You're going to notice that if we start here, there's not a circuit, okay? Because we'd have to travel along distinct adjacent edges. So if we start here and go to B, then to C, then to D, then to E, then back to B, then to A, we actually traveled along this edge here twice, so that's not allowed. So that's not a circuit, okay? Is there a circuit in this graph? Well, the answer is yes. And you can probably guess what it is. You just can't start out here. If I start at B, if I was right here, I could go from B to C, C to D, D to E, and then E back to B. So it's basically similar to a path. You're traveling along distinct adjacent edges, but the only difference is in a circuit you wind up finishing at the same vertex that you started at. And you could call this a circuit of length 4 because you traveled on 4 edges. So now that we've talked about paths and circuits, now all of these are always going to be related to connected graphs. We don't have to worry about disconnected graphs when we're talking about these. Now that we've talked about paths and circuits, we can talk about Hamilton paths and Hamilton circuits.